All right. Little review. The first one is an ellipse. How do we know it's an ellipse? There is a plus sign in the middle. All right. Ellipses always have plus signs in the middle. And so for this first one, we would divide everything by 36 and reduce it. So I get x squared over 9 plus y squared over 4 equals 1. And then remember, in the x direction, we go a distance of 3. And in the y direction, we go a distance of 2. And that makes our lovely ellipse. And then we find the focus. And the focus is always the square root of the bigger one minus the smaller one. All right? And you always take these numbers up here from the original equation. Okay? And that gives me the square root of 5. And then how do we know if we put them on the x-axis or on the y-axis?
Whichever one's longest.
Yeah, the major axis, which happens to be the one that is bigger. When you're doing ellipses, it's the one that's bigger. So this is like 2 point something. And so this coordinate point is negative square root of 5, 0, and positive square root of 5, comma, 0. So what's the definition of an ellipse, you guys? So it is, remember I did this little string demonstration for you guys? So the distance from here to here, if you add those two, is the same no matter where you are, all the way around the whole entire ellipse. So it's the sum of the distances from the focuses to the ellipse is the same all the way around. Okay. So we did standard form. Standard form is this. So I'll put that right there. I guess I should list my vertices. So those would be negative 3, comma 0, positive 3, comma 0. And the y ones would be 0, 2, and 0, negative 2. All right, this asks something a little new. I don't think we've had this for a while, but just in case you need to know this in the future, wink, wink. Major axis length is what?
6.
Yep, so the major axis is the bigger one. You count all the way across. Its distance is 6. And of course, the foci, we have the square root of 5, comma 0, and negative square root of 5, comma 0. So that's just a little review. So a hyperbola, the definition of it is it's the set of all points where the difference of the distance to each of the foci is constant. So this time we go from foci to foci and we touch the hyperbola right there. If you subtract this minus this, it's the same no matter where you connect. Okay? So the big important part of this is that you need to look for minus signs. In order for it to be a hyperbola, you're going to have a minus sign in the middle instead of a plus sign. So if it's a plus, you're drawing an ellipse. If it's a minus, you're drawing a hyperbola. All right? And this time, you want to look at which one is positive. So in this case right here, this first thing is x squared over a squared, and it's the one that's positive. All right, there's a negative in front of the y squared piece. So if it's positive, it's going to look like this, where your vertices, these 2 points here, are on the x-axis. All right, so maybe draw a little arrow. If the x part's positive, you're going to have what's called a horizontal hyperbola. All right, it's going to look like that. And if the y is positive, so here it's switched around, and now the y is first, and it's the one with a positive in front of it, now you're going to have a vertical hyperbola. Or, in other words, the vertices are on the y-axis, okay? We will find the asymptotes. We'll look at the rise over the run, and then the formula for your foci for this one is... So the other one, you guys, was the bigger one squared minus the smaller one squared. Now we add the two things that are underneath right here. And if you want to write it like this, I usually just do the square root That's the same thing, okay? And again, it comes from Pythagorean theorem. So how do you remember? Well, remember that ellipses are plus in the middle, and so their formula for the foci is minus. It's opposite. And this one is minus in the middle, so the formula for the foci is plus, okay? Let's try a real problem. Sketch the hyperbola. All right, first thing we have to do is put it in standard form. So just like before, we need to divide everything by 36. So I get y squared over 4 minus x squared over 9 equals 1. So which one is positive is now what we're looking for. The y. All right, the y is the one that is positive. So that means that I'm going to go on the y-axis. I'm going to go up 2, because that's the square root of 4, and I'm going to go down 2, because that's the square root of 4. And we're going to have these little circular things, right, our little parabola-looking things, but don't draw them yet, okay? Now on the x-axis, we're going to go over 3. Don't put a point, just put a little dash, and we're going to go over 3. Just like we would with the ellipse, right? That's the x distance. What this does is it actually makes our box. So I want you guys to now put 4 points. 1 here, 1 here, 1 here, and 1 here. So you make a box that goes out 3 and 3 on the x, and up 2 and down 2 on the y, okay? And this makes asymptotes. So I'm going to draw in some dashed lines connecting my box straight across. So the box, all this does is helps us set up our asymptotes. Again, it is a y graph. So this is going to be vertical. And then it's really important that your lines, they make a curve, but they get really, really close to the asymptote. Like they just start to touch it like that. And same with this one, but they don't ever actually touch it. Whoops, like I did right there. But you got to make sure that it starts almost looking like a line. So you can't go like this. Boop. Okay, you're going to lose points if you do that. You actually have to make it really, really close to the asymptotes. And I guess this matters for calculus, so do it right. All right. And now we got to find the foci. So my formula this time is going to be the square root of, and instead of subtracting these two numbers, we add these two numbers. So we get the square root of 13. And if you do it wrong, you'll probably notice, because it probably won't look right, because your focus points should be inside these curves. Okay? So the square root of 13 is somewhere between the square root of 3, 9, and 16. So 3 point something and down 3 point something. So this is the point. Yep. 0 square root of 13 and 0 negative square root of 13. So we did standard form. That's right here. You can fill that in. Vertices. This time there's only 2 vertices. So we can actually write our vertices as 0, 2, and 0, negative 2. These points here. And then our foci, 0 square root of 13, 0 negative root 13. And the last thing we're going to do is our asymptotes. So you guys, it's just the equation of this line. And luckily this line goes through 0, 0 right here. So all I need is the slope, and I'm going up 2, right 3. So it's this distance of 2 and this distance of 3 that comes from right here. But you got to look at your lines, okay? So make sure you graph them really nicely. And it's plus and minus 2/3 x, because this guy's a positive slope, this guy's a negative slope. Everybody good?
Yes.
Cool, let's try one more. Sketch the hyperbola. All right, vertices, there are only 2. So we care about which is positive. So Evan, which one's positive?
The x is positive in this one, so it's going to open horizontally.
That is correct. And so, Harrison, my vertice coordinates are going to be what? You're trying to do both. We just need the one that's vertices. The other one makes the box, right? All right, so let's put these on the x-axis. Why are we putting on the x-axis? Because this is underneath the x, and the x is positive. So I'm going to go over 2 point something, and to the left 2 point something. It's really close to square root of 4. And again, it's going to look like this and open out this way. Now we make our box. So underneath the y is a 16. So Dylan, we're going to go at what distance in the y distance? Yep. Up, whoops, and don't put points. Just put like little dashes because this makes your box. Okay, now I make a box. Point, 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 and point. I kind of got a little off there because I put them at like 3, but I really should have put them at, yeah. Whoops. That was weird. All right, now we draw our asymptotes. And draw in your hyperbola. Whoa. That was terrible. It should be curved. Whoops.
Cut that across the line. That's inaccurate.
Yep, inaccurate. It's really hard with this board, I promise you. It's way, you got this. I believe in you. Focus. So now let's do the focus. So we got to do, for the focus, Thomas, are we going to add or subtract? Good. So because it's minus, it's opposite. So your C on this one is the square root of 5 plus 16. And the order doesn't actually matter when you're adding them, right? When you subtract them for the ellipses, it does matter. You do the bigger minus smaller, otherwise you get negative, which wouldn't really work. All right, so I get the square root of 21, which is really close to what? Or in between what two numbers? 4 and 5. So this time, this is like 4 point something. So from here, I'm going to go over to 4 point something. My focus points have to be inside of the hyperbolas. Right there. And this time they're on the x-axis instead of the y-axis. So when you write your point, it needs to be the square root of 21, comma 0, and negative root 21, comma 0. And then for our asymptotes, we need a slope. So, Kelsey, what's our rise over our run for this one? Yep. Kind of weird. But so it's plus and minus 4 over root 5. So I went up 4 and over a distance, the square root of 5. And then you have to rationalize that. So I multiply by root 5 over root 5, which gives me that. All right, you guys are going to try this one.
Yeah.